Hi everybody, and welcome to this month's .NET user group. I'm going to be talking about Blazor web apps and why we can pretty much say goodbye JavaScript. Now, as a .NET developer, I find there's a few pain points that we have to go through when setting up a new web application. When it comes to frameworks like Angular, if you haven't used it before, it's got a fairly steep learning curve and it's very opinionated. So if you want to do something just a little bit different, the framework just says no, you can't do it. You have to do it only the way that I say you can do it. And sometimes that can be quite annoying. With React, for instance, it's maybe a bit more flexible. You can do different things, but it doesn't come with everything that you need to build a full application like you do with Angular. You have to start pulling in packages from other places to stitch together your full application. Now, I find these JavaScript frameworks, they rust pretty quickly. What I mean is after I do npm install and my first production build, it's just about time to update everything again because there's a brand new version available. And JavaScript. Not everybody's favorite, but it's dominated web development for about 20, 25 years. And for a long time now, it's been sort of the only choice that we've had. There is TypeScript. It's a whole lot better. You get a lot of similarities between TypeScript and C#. In fact, it was written by the same person, Anders Hellsberg. He wrote C# and TypeScript. But we still find a lot of these weird JavaScript tricks around the place, and it just doesn't sit well with some C# developers. Now, it's also when we build our applications and we need to tie our backend API to the front end, we need to translate our C# classes, our models, into TypeScript interfaces, just so we can serialize them, send them across the wire, and deserialize it on the other end in a different language, totally different language. And I find that's a lot of effort for something that should be fairly trivial. There has to be a better way. Then to debug our applications, using Visual Studio Code, you can debug the backend API. And then when it comes to the UI, I have to use the browser. And jumping backwards and forwards between the different tools to debug my application, it does get a little bit annoying. And I hope there is a better way. But first, a little bit about myself. My name is William Liebenberg. I'm a solution architect at SSW, and you can find me on Twitter. I have a blog site called Azure Gems, and you can also find me on LinkedIn. So I started programming when I was about 5 years old, and when I mean programming, I mean copying text from my dad's programming book and typing it into the computer and seeing something happen on the screen. It was very exciting. I had no idea what it actually meant, but it was cool. Now, my first computer was a Spectra Video 328. It had a massive 8 kilobytes of memory, and I could load games and other little programs from cassette tapes. So this is long before CD-ROMs and the internet was out. So this is what we had. This is sort of like my Xbox and my little programming computer, everything all in one. Really, really enjoyed it. So then many years later, I moved over to develop professionally using C and C++. And I spent a bit of time writing games and graphic engines. And then, this is also when our IDEs were fairly low res compared to today's standards. But, we felt like we could rule the world with our source code and the applications that we were writing back then. And then along came .NET. I started with .NET version 2. I skipped version 1 because I thought, what's this crazy new technology? It's not going to last. But hey, look, many years later, we've still got .NET and we love it. And I fell in love with Azure around 2014, and not a day goes by now that I don't do something Azure related in my day-to-day job. It's definitely got something for everyone. So if you haven't used it before, just go check it out. So today's agenda, I want to dive straight in. I want to show you how easy it is to build a Blazor web application in 5 minutes. Then I want to cover just a little bit of history to sort of explain why we have Blazor. It's very, very interesting. And then I want to convince you about why you need to use Blazor. In fact, I'm just going to say you have to use Blazor. It's awesome. Then we'll look at how to use Blazor in enterprise. And when you talk about enterprise, you can almost not talk about clean architecture. They go hand in hand. So we'll see how we can use Blazor in the real world. And then also just see how we take our Blazor application and run that or host that in the cloud. What are our options? So to get started, we can open up Visual Studio, go File, New Project, and choose a Blazor application. Or we can go and use VS Code and just use a .NET command line interface to spin up a brand new Blazor WebAssembly application. And I'm going to do that right now. I'm just going to go over to my console and go .NET new Blazor WebAssembly. I just need to give this a name. So I'll give it Blazor .NET user group. Yep, that should work. So this is going to spin up a standard template or standard project. It's going to see restore a couple of little NuGets for us. And in a moment that should be done. And yep, now I can open up VS Code. So let's go to Blazor .NET user group and open that up. All right. Okay, here we go. Here's our application. I'm just going to give VS Code a moment to load itself. It's got to prepare a few things. Might show a couple of pop-ups for us. But let's look at what we have in our application. So like all good programs, we have a main method and basically only 4 lines to get a Blazor WebAssembly application up and running. We've got a WebAssembly host builder. We're adding a root component called app, and we're sort of identifying it with this another app tag as a text value. And then here's something familiar, add scoped. So this is dependency injection. So we're adding some pre-configured services into our application builder. So this is a HTTP client that's pre-configured to point to our base address. And that's it. Then we'll have everything we need to start running our application. So this is just asking me if I want all the debugging assets. I'll say, yes, please. Give me that stuff. All right. And while it's doing that, very familiar CS project. You can see that this is .NET Standard 2.1. There's a bunch of WebAssembly NuGet packages being brought in and a new HTTP JSON package. So this is the HTTP client that runs in a browser, and underneath that it uses the fetch API to make our web requests for us. And finally, we see here that it's got the Razor language version 3. So Blazor uses Razor for its markup language. So they took the words browser and Razor, put them together, and we came up with Blazor. True story. So we saw earlier that there's this app component, and here it is. So this has got the main router for our application. So any component or any route that we give to our application, this will resolve that and figure out where to go and what to display. So if there is something that is found, a route that resolves into an actual component, use this main layout type to display our components. Now, if there's anything that's not found, so we typed in a weird route into our application, it will say, sorry, there's nothing at this address. Nice and simple. Now, in this class, or in this component, sorry, we will be adding a whole bunch of other stuff. We can add our authentication checks, whether they are logged in or not logged in, and we can redirect them to the right place. And there's online, offline mode, for instance, if we're dealing with progressive web apps. But yeah, so this is a very important file. So we add quite a lot of overall or cross-cutting concerns into our application right here. We also have this _imports file, and this is interesting because we can bring in, by adding a using statement, an entire component library. So we can reuse those components in our Razor files without having to, again, add a using to our files. Now, this only applies to the Razor markup files, as we'll see shortly. You still have to use your normal using statements when you're writing a plain C# class. And again, so here, something very familiar, a www root. We have an index.html file. And we see here, it brings Bootstrap in by default, just all the Bootstrap CSS. We've got some custom application styling. And here's our app component that's being rendered inside of the HTML, index.html. And so this is where, once that component is loaded, it's going to replace this with whatever resolves out of that. Whatever route we give it, it's all going to render in here. So it's going to replace this with our UI code. And very importantly, what makes all of this possible is the Blazor WebAssembly JavaScript runtime framework. So this lets us essentially load the .NET WebAssembly runtime, and then we can run all our custom C# code, all the DLLs that we give it, just standard C# or .NET standard 2.1 DLLs, and they run in the browser. It's going to be very exciting. So something else, let's see, we've got a nav menu. There's a main layout. So we see here, it's a sidebar with our nav menu, and here's a special sort of @body render fragment. So we can see that this is a layout file. So when the router resolves an address for us, it's going to know which component or which page we want to render, and we're going to take all that content and render it in this render fragment called body. So now I've mentioned the nav menu. We'll be looking at this a little bit later as well. We're going to add a couple of links. But we can see here that there's a link to a page called counter with a href of counter. Same with fetch data. So we'll look at this. So here in pages, we've got a counter component, counter.razor. You can see here it's got an @page directive with /counter. So that's a route to get to this component. And we can see that it's printing out a current value. There's a button with an on-click event that says increment count, and F12 onto that, IntelliSense works. Hey, we get to this method that increments the count by 1 every time we click on it. So this is normal C# code. It's just sort of tucked into this little @code directive on this component, the Razor component. And then fetch data, it's a bit more of a complicated thing, shows us a table, renders a data by looping through a list of forecasts. And as we can see here, that when the component is initialized, it loads some data from currently just a JSON file. But we can actually call any sort of HTTP endpoint to obtain information. And inside of our code is a sort of nested class called weather forecast. So that's a concrete type of what we want to use to display this information. All right. So we should have everything we need now. If we go and press F5, the application should just run. And here we go. So it's got the browser open. So when the first time you run this, it does take a moment for a whole few things to download. And when it's done, voila, here we have a Blazor single page application. Got the home page. Got our counter page that we saw before. This is what it actually looks like. We go click on the button, we can see the numbers increasing, and we have the fetch data page. Cool. So very simple application. It's got a couple of things in it. And what else can we look at? So if we open up the dev tools, we can straight away see there's this little Blazor highlight here that says it loaded 6 megabytes worth of resources, which is quite a bit. And if we dig into that, we can see here that it's downloading components.forms or DLLs, the actual .NET DLLs, Microsoft extensions and components and system.drawing. There's quite a lot of stuff in here. But what is a bit different here is that this is .NET.wasm or WebAssembly. We can see it's about 780 kilobytes. In size. So this is the .NET runtime that's been compiled into WebAssembly as a minified code that is responsible for or able to take a normal .NET DLL and run it in the browser. It's certainly amazing. We're going to see how we can use a lot of our favorite packages, even packages that existed before Blazor. We can even run them in the browser right now. We also see there's this cool little debugging hotkey, Shift-Alt+D. All right, so let's try that out, Shift-Alt-D. Okay, so what have we got here? It says it can't find a debuggable browser tab, but it gives us a hint. So there's a command that we can run from the, if you go Windows+R, so you can run this command that will open up a new Chrome, or you can even use Edge, obviously, that has a remote debugging enabled. So if we just run that, Cool. We get a second instance of Chrome. So don't close the one behind it. If you do, it stops everything. And then again, we just try that hotkey. That opens up DevTools, but a slightly different version of DevTools. Because if we go and look at the Sources tab, something very special. Now we actually see all the C# code for our application in the browser. That's interesting. Here's our nav menu, so all the markup. Here's some C# code. Here's the code for our counter. That's pretty cool. And look at that. We can set a breakpoint. So when I go to my application, I'm going to go to the counter and I'm going to click the button and look at that. It's stopped on this line. And what we can see here, some interesting stuff. We've got the call stack and we've got all our locals here. If we expand that, you can see the current count is 0. So let's just make it go one line further and go continue. Now the current count is 1. Awesome. Cool. And it's reflected here. It's 1. So if you try that again, the breakpoint's hit. See the current value is 1. Move over one line. Now it's 2. So awesome. We can actually debug a .NET or C#.NET application running in the browser with all the C# code available in the browser, in the DevTools. It's really cool. Really, really cool. It's definitely going to solve a lot of my pain when I want to build my applications. Now, let's just undo these. I'm going to make that continue running. And yeah, the same for all the other components. So it's all there. All very cool. We can dig a bit deeper into seeing, what is really there. Here's all the DLLs and the sizes and things that we saw from before. You can see there's quite a lot that goes into running a Blazor WebAssembly application in the browser. But when we publish our application, for release, it's a lot smaller. So all the unnecessary code is all stripped away, and sort of just the bits of the framework that you need are then bundled into your application. Cool. So I'm gonna close these for now. I'm gonna go back to Visual Studio Code, and let's see what else we can do. All right. So what use is a component if you can't reuse it? So you see we've got this counter one here, and it's got a route called /counter, and from our nav menu, that's where it goes. Okay, so it goes to the counter route. But what we could do, just to prove a point, we go into our main page here. I'm just going to delete that for a second, and we can then go and add a counter. You can see already it's discovered our counter with IntelliSense. So, and the code complete's working. Cool. All right, so our counter is there. Now I'm just going to build my application. I'm just going to start this up in a slightly different way, because what this does, I'm going to do .NET Watch build, and as soon as I make sort of code changes, it's going to watch for any changes and it's going to rebuild my application, and all I need to do then is just refresh the page in the browser. It's not quite the same as the live hot reload that we have with React and Angular, but it's sort of halfway there. The live hot reload for Blazor WebAssembly is coming in a future .NET version. So that's very exciting. Okay, that's built. I'm going to press F5. I'm just going to launch the application again. And now here on our Hello World page, we have the very same component, and it works in exactly the same way. Very cool. Very cool. All right. Very nice. So I can close that. I want to show one more thing. So we can actually, this code that we have here, we can also debug it in Visual Studio. In Visual Studio Code. So I'm just going to set that breakpoint here. So the bright red means it's going to work. And if we launch the application, and so we set it on the counter increment. So I'm going to hit that button. Visual Studio Code should highlight for me. There we go. We can see here, I'm just going to open up the debugging tools, and I'm just going to close all that, make it a bit bigger. So now we can see we're broke on this line. We've got the current count, and just like before, if we just put a breakpoint on the next line, we continue, and we can see that should have gone up to 1. Cool. So very much exactly the same debugging experience. We can actually debug the whole application in VS Code or in the browser. You don't have to keep jumping between the two. You can stay in one place if you really wanted to. And here we go. It hits it again. Cool. All right. Let's continue. Okay, so it's very easy to see that we can debug an application. It's easy to add components, and we just looked at a hint of the routing and how to add links to our pages. So I'm going to go back to the slide. So that's how we build a Blazor WebAssembly application in about 5 minutes. Nice and easy. So you can do it with Visual Studio or with Visual Studio Code and the .NET command line. All right. So next, we're going to look at a little bit of history. How did we end up with Blazor? Why is it there? So it all started with .NET Framework version 1 in 2002. This is exciting. Like I said, it came out. I didn't think it was going to be an amazing technology, but sure enough, many years later, we're still using .NET, now .NET Core, and it's definitely my favorite. Then Silverlight came out in about 2006, and that was a plugin for the browsers where we could write some C# applications, and the Silverlight plugin would then run that for us in the browser. So that's pretty cool. .NET in a browser, it's amazing. But then jQuery also came around the same time. And then something interesting happened after this. Apple released their iPhones, and then also the Android phones came out, and the HTML5 spec was basically finalized. And now it meant that everyone with a phone in their hand basically also had a browser with them. But the twist is that the iPhones just refused to run any plugins in the browsers. That you couldn't load Silverlight as a plugin to the browser, so we couldn't run any of that .NET code on the phones. And now then with HTML5 being finalized, and then also AngularJS came out, it kind of meant that everyone was sort of able to use this new awesome web pages written in AngularJS and similar frameworks on their phones, on their laptops or desktops, and but you couldn't use Silverlight in any of the scenarios. And basically then in 2011 with Silverlight version 5, that was the last version, and rest in peace, no more Silverlight and no more C# code in the browser. Then React, very popular. It came out 2013, the very first version, and it came out at the same time as assembly.js. Now assembly.js was pretty neat because you can take C or C++ code and run it through a particular tool chain, which let you then run that C or C++ code in a browser. So it takes that code and compiles it into bytecode that is sort of optimized native JavaScript, runs in the browser, and pretty much at near native speeds. So it's really fast. In fact, it's so fast that they took the Unreal 4 gaming engine, ported that to ASM.js, and ran it in the browser. It's really, really cool. And then we got .NET Core a couple of years later, 2016. Very cool. And WebAssembly, not long after that. So WebAssembly is a little bit different. Now it opens the gate to not just sort of C or C++, but other languages, so F# and Ruby or Rust, and there's now the ability for every type of language to run their code in the browser. And all the browsers then also supported WebAssembly. So Safari, Edge, Firefox, and Chrome all run WebAssembly. And then Blazor got announced by Mr. Blazor himself, Steve Sanderson, just as an experiment to see, can we take C# and compile it down with WebAssembly so we can run it in the browser. And so this was just an experiment. It was very exciting. And like about 2 years later, Dan Roth announced that Blazor is an actual preview. Microsoft is going to give this a good crack and see how it goes. And so that was in April 2019. And very shortly after, they said, hey, look, Blazor server, we're going to support it now with .NET Core 3. And so we've had Blazor for a little while, but in Blazor server. It's a little bit different to Blazor WebAssembly. But Blazor WebAssembly, it was around, but then it was actually officially released in May this year with .NET Core 3.1. So we now have Blazor WebAssembly, and it's pretty damn exciting. I quite like it. A little bit into the future, we're going to have Blazor LTS, so when things become long-term support. So with .NET 6, it means that Blazor is actually going to be around for a long, long time. So now, like I said, Blazor is awesome and you really need to use it. I'm going to show you why. I'll give you one very good reason why. That is because we can write our C# code in the browser. And for me, that's almost just enough to convince me to jump in right now and start using it. But I'll give you a few more reasons. There's no plugins required whatsoever. It's not Silverlight. Blazor is definitely 100% not Silverlight. It's very different. Our code runs directly in the browser without any plugins. It's a fully .NET-based single-page application framework that we can use to write applications very much like that we used to with Angular and React, but with less pain. And something that's very familiar to a lot of .NET developers will be the Razor templating engine. So if you have the experience from the MVC area, you can then use Razor with Blazor to then write client-side applications. So there's no more server-side rendering, but client-side. It's pretty cool. And you can add all your very own C# code that runs alongside your Razor templates in the browser. So we'll get a full .NET tech stack, so all the very much familiar tooling that we've been using. And one really cool thing is that we can share code between the server and the client. So we don't have to take our server-side models and translate them into TypeScript interfaces. We can just literally take the same code from the server and run it in the client, and there's no more headaches. And we actually get to use all of the existing .NET NuGet packages, as long as it's .NET Standard 2.1. So all our favorite stuff like Serilog and Mediator, Fluent Validation, all of those libraries, we can take them from writing our backend applications and actually use them in a front-end application. Pretty cool. And Blazor is built to be stable for many, many years. So once we hit LTS, it's there for good. It's definitely going to be a long-term technology, and it's not like the rusty technologies from the JavaScript world that change so often. I think Blazor is going to be stable and be supported for many years. Okay, so WebAssembly, or WASM for short, it's a standard web technology that is now supported by the major browsers for a few years now, since 2017, and it takes our code and compiles it right down to bytecode, and we transmit that in as binary. Whereas with JavaScript, it's all sort of minified down but it's still text. So it's transferred as text. So it can't get any smaller than that. The same sort of WebAssembly application will be a lot smaller than a JavaScript application once it's compiled. And the benefit is that they run at very near native speed. So it definitely can get a speed boost from running a WebAssembly application. And WebAssembly still has the same security sandbox that we used to with JavaScript. So when you're running code on the client side, you can't dig into the Windows registry or mess with files on that computer whatsoever. It's just not allowed. And we're used to that with normal JavaScript applications, and this is no different. But we don't have to use just C#. There's other languages. So F#, Python, Rust, and C, C++. All of them are supported by WebAssembly. So you can write code in those languages and then run it in the browser. It's really cool. So which flavor of Blazor do we need to choose? On the one side, we've got Blazor WebAssembly, and all the logic that we write is executed on the client. So we offload that compute from the server to the client. So some really good benefits in doing that. And we can see in the diagram here that we've got our .NET code and our Razor components running on top of WebAssembly. And with all the user interactions, it directly sort of updates or incrementally updates the DOM for us based on those interactions. So it's nice and fast. It's very similar to how Angular, React, and Vue work. So single-page applications, they have all got their own ways of manipulating the DOM, but essentially it's the same thing, client-side logic. With Blazor Server, the story is a bit different. All the logic is executed on the server, and all the rendering is done on the server. And it just transmits the DOM updates to the front-end application using SignalR. And there's got some ups and downs with that, but for me, the downside is the further away from the server your client is, then you start introducing latency, which, if you have a sluggish web application, it definitely doesn't give a good user experience. So the pros and cons about Blazor Server. There are definitely some pros to Blazor Server because there's no initial download size. So you see with the Blazor WebAssembly application from earlier, downloaded a whole lot of DLLs, and there's a minimum download payload size of about 700, 800K for the .NET runtime. So you don't have that with the server-side flavor of Blazor because the rendering's done on the server. It basically just spits HTML out to the browser and it renders it. So it's fast to load. You can run it on pretty much any browser from any era. You don't need any modern browsers, so you don't need to have one that supports WebAssembly. And one of the other benefits is that all of your code, all your business logic stays on the server. It's private. It's definitely no way of leaking that out to the client whatsoever. And you have the freedom of much bigger security sandbox where you can work on files on the server. You have pretty much got bare metal access to that hardware. The downsides is, like I mentioned, the latency. Signal R for each user interaction, that communication overhead can build up, especially over long distances. Now we also then have the responsibility of making sure that those connections remain active. So if the client connection is dropped, essentially the client application is dead. It can't do anything, can't react to anything, it can't receive updates, and it can't send updates. So definitely have to do that ourselves, which is a bit of a pain. And we have to maintain the client state on the server, so it has a copy of the DOM for each client, and that can lead to some fairly big amounts of memory being used up. So it's a heavy application, also a heavy framework, and it means that it might not be able to scale as big as what we'd like. And certainly, like I said, there's no offline support. Once that connection's dropped, that's it. Your client applications can't function. So now let's look at the pros and cons of Blazor WebAssembly. Again, it's a bit different to Blazor Server. In fact, the difference is that we can run our .NET code in the browser. So it's not server-side, it's all client-side. And running at native speeds, we can share our code. We don't have to translate anything from C# into another weird language. It's plain C#. There's no dependency on a server-side technology. So even though we would like to use an ASP.NET Core backend, it doesn't matter. You don't need to use that. It can be completely standalone on its an application running in a browser, or it can be a standalone application with a Node.js backend. You're not tied to any backend technology whatsoever. And these applications can scale because it's a static website. You can put that on a CDN and get that much closer to your users than you can with a big clunky server. And it's just nice and easy. And then PWAs, Progressive Web Apps, they're also supported with Blazor WebAssembly. And what that means is we can have offline support, and we can install the application as an icon on the home screen on the phones or on the desktop on the computers. And yeah, there's a lot of the cool things that we'd like for client applications. The downside is it does have initial download size, at least 700 kilobytes plus all the additional application DLLs that we want to use. We do need a modern browser, so you have to support WebAssembly in that browser. We're limited to the browser sandbox, but we're used to that already, so it's not really a major issue. The tooling for Blazor WebAssembly still needs to mature just a little bit. Sometimes the IntelliSense just seems to stop working, and you have to close everything down and start back up. But it's not a major problem, not really. And we're missing the live hot reload. So this is great for productivity. So even though we don't have it now, it's coming. But at the moment, the alternative is we have got the auto rebuild. The only difference is we have to press F5 in the browser to get the updates. It's not going to automatically do that for us. But like I said, it's coming. So which one should we choose? We've got Blazor WebAssembly, which is sort of the lighter sorbet flavor, or Blazor Server, which is a heavy chocolate ice cream with extra cream and a cherry on top. For me, I'm going to choose Blazor WebAssembly. I like the lightness and the simplicity of it. I basically can focus on just writing a single page application. I don't have to worry about managing so much client state and everything else. So I'm going to go with Blazor WebAssembly. So you're thinking already, get to the code. All right, so let's look at some component anatomy. This is the basic layout of a component. We start off at the top with the directives. This is where we say use @page to give the component an address, so we can route to it. We bring in any sort of other component libraries or class libraries that we want to use with the using statements, and we can then inject services using the @inject directive. Now, there are a few more. For instance, we can say which layout we want to use for this file, etc. Then in the middle, we have our markup code, HTML markup, and some Razor code, which allows us to decide what we want to display and when we want to display it based on some conditions. So we've got some nice flexibility in the rendering there. And then finally, we've got the code. So the @code directive can take in a block of C# code, and it is pretty awesome. So that's the basic layout of a component. And this is as simple as a component gets. What we have is just a heading and a paragraph with a message that is bound to the message string inside of our code. So when the page loads, it's going to read the value from message and display it on the screen. Now, the difference between a component and a page is just by us adding the @page directive and giving it an address. That's the only difference. But what is really cool is, let's say we've refactored our components a bit, but there's a route out there that people might link to for an old component that we've replaced. So we can actually give one of our pages or one of our components multiple addresses. So you can actually have a second one, a completely different name, but it'll still route to this component. So it's pretty nice. Some people like to take their Razor files and split them up. So we have on the one side, on the right-hand side, have just the view or the markup code, and on the left, we've got the code behind, the C#. Now, the way that we actually have to make this work is, first of all, we always have to bring in the components, the ASP.NET Core components, using a using statement. And then we can make our class a partial class for this component. And the names for the component and the razor.cs and the Razor file, they all have to match. And that is the way that then the compiler will pick up all the relevant files and stitch them together. So just like all the other frameworks, our components, they have life cycles. So we have a lot of methods that we can use to react to things happening to our components. And we can decide when to load data, or when and when not to render the component, and what to do once it's rendered already. So there's a lot of options here, and you can build some really complicated components and build some really rich UIs. Data binding, very important. So in this example, we have a one-way data binding just with a single @ symbol to the title field in our code section. So see, making sure that the names match. So when the page gets rendered, it'll render that title field. Now what we'll have next is a two-way binding. We've got an input text box, and we've bound the value of that text box to our title property, or title field. But the default event take place is the onChange event, which means once we've tabbed out of the input box, or once it loses focus, that's when it will update the title value. But that's a bit clunky sometimes, and what we want is to be able to update the title as soon as we type. So for each keystroke, we want to update the title. And again, we can do that with data binding, a two-way data bind. We start off at bind to the title, and then we can specify which event we want to bind on by using this colon notation here to specify the onInput event. So now each character that gets input into the input box will straight away update the title value. Pretty nice. So parameters. What we do with parameters is that we can give an optional parameter to our component via the route or the page directive. And we can see here the text route or text parameter, sorry, is bound to the text field, and it must have a parameter attribute. It's the only way that they can be linked together. And we can see there in the onInitialize method, we can see, because it's an optional parameter, we're seeing, hey, is this text null? If not, use that text. Otherwise, just replace it with the default value. So if no one gave this component any optional text, it's going to say Blazor is awesome. Otherwise, it's going to render whatever it gives, the user gives us. And then we bind that to the @text field there in the view. We can add some constraints to our parameters. In the previous example, we just had a plain text field, but now we can actually make sure that for this ID that we're expecting, we want to make sure that it's an integer. So we can specify the type on our routes as well. And we can see here, then again, it's a parameter. We have to have the parameter attribute for this ID, but now it's guaranteed that this will always be an integer. And we can data bind to it and it'll display the correct value. We can also use a whole bunch of other types, not just text or string and integers. We can use datetime, GUIDs, longs, booleans, all the reference types are there. We can use them in our constraints. Handling events. So if we've written a component that allows us to react to an event inside of it. So in this instance, we've got a product title printer that gives us an on-click callback that says once this on-click is fired, I want or you can at least call whatever method you want. So in this case, we've got a method called clicked, and it receives a string value for that product. You can discover that the IntelliSense just shows you what it is. It's nice and easy. You don't have to go and dig through the code to find out what the method signature is. And then, so we're just going to print out the product name of what was clicked on. So this is then what that product title printer component looks like. We have a couple of spans that shows the title and the description, and then a button that when the button is clicked with the on-click event handler, we then invoke our on-click event callback, and we pass in the title property to that callback, which is then received by the calling component. And that's it. So that we have bound a method from a calling component to the event inside of a component. Nice and easy. Very important. We've talked about routes before, and now we're talking about navigation. So how do we go from one page to another page? We do that by injecting the navigation manager. And what we do is, so in this example, we've got a button. Once we click on this button, we're going to call the navigate to where the page method. And that method, it uses the navigation manager, and there's a navigate to method there, and we just give it a component or page name, and straight away it routes our users to that component. Pretty simple. Now, dependency injection, very important. This is where we can take care of setting up all our services that we want to use in our application. So they're pre-configured, ready to go. As soon as our components receive them, they can just start using them. So they don't need to know about the particular config, or in this case, the address for the HTTP client. It's all taken care of. It's out of the way. We just get to use it. So in our component, we have to inject services using the @inject directive. We give it the type, in this case, HTTP client, and then we give it a variable name, HTTP, and then we can go and use it. And in this case, it's just calling a REST endpoint to get some weather forecast information. Cool. But things are a bit different. When we work with the code behind approach, we don't see the @inject directive anywhere. What we have to do, like all code behinds, you have to bring in the ASP.NET Core Components namespace, and then to inject the service, we have to do it via parameter injection. We use the inject attribute on our service, in this case, again, the HTTP client, and you'll notice there's no constructor injection. There's only parameter-based injection. But for our normal C# classes or services that we write inside of our Blazor WebAssembly application, there you can use your familiar constructor injection. It's only for the Razor components that you have to use the inject attribute. And then it's available and ready to use just like normal. Now logging, very easy. We can just use console.writeline, and it certainly works. It's very, very easy, but it's also very boring. I think we can do something a bit better with logging. So out of the box for Blazor WebAssembly, this ASP.NET Core is available. We can use the iLogger. All we need to do is we can set up the logging level that we want to log at, so we can make it more noisy or less noisy, depending on what we're trying to do. And we inject an iLogger for our component into our component. And then we can just use it. Logger.log warning and does the job. Nice and simple. But we can do one better. We can actually use Serilog for logging in the browser. Pretty cool, right? So I'm going to show you how to do that. I'm going to go back to VS Code and I'm going to go and add a new page. So this is our nav menu where we were before. Excuse me. And I'm going to add a new page. But before I need to do that, I'm going to bring in a couple of NuGet packages. So just open up a new terminal here. .NET add package Serilog. All right, so that's just going to download Serilog for me. Cool, done. I'm going to add another one. So it's just a special, so Serilog's all about syncs. So I'm going to add in a Serilog.syncs.browser console. And this is a pre-release. Let me just make that a bit clearer. So this is a pre-release NuGet package, so you have to specify that exact version. So it's let me see, it's a version 100-dev-0012. All right, I memorized this one, by the way. Took a while. Okay, so that's in now. So we can just confirm that. We'll look at our CS project file. We can close this. And we can see, hey, cool, we have a couple of new package references. All right. So back to the nav menu. I'm going to grab some code that I'm prepared. I'm just going to put that in here. So essentially, we're going to have a new link on the side menu. We can see here that the href is logging, and the title for this link is logging. So we need to go and add a new logging.razor file. And all the Razor files should start with a capital letter. That's in the documentation. It is absolutely required. Now what we need to do very first is to give our logging page a route. I'm going to call this /logging. So this is what we put in the href for our nav menu. Next up, I'm going to bring in Serilog. Cool. And I'm just going to add the at code section. So what we can do now, I want to add a couple of buttons that I can click on to log messages. So I'm just going to put them in here. So I've got 3 buttons to log a message, a warning, and an error. We need some code to do that. So what do we do? So we've got the 3 buttons and they all have an on-click event to a method. And here are all those methods. Just nice and simple. Log information, log warning, log error. Okay, so my build should be running. Yep, so it did save everything and it did rebuild it. So, and the application's running. So I can just tab back to my application, hit F5 to refresh. Now we see we've got a logging page and, oh, sorry, nothing at this address. What did I do? So we got logging. Did I mistype logging? Let's have a look. Logging. Where's my nav menu? Logging. What happened? Logging. Ah, should be all right. Let's double check. Let's reload this application. Ah, there we go. Now we've got 3 buttons, log with Serilog and log warning and log error. So I'm just going to open up the dev tools again. So this is where we should see our messages. Click here. No, okay, I must have a little error in my compilation. What did I do? No, that's calling the right methods. Let's see, Mr. Demo, you need to work. Oh, I know exactly what the problem is. We forgot to set up Serilog. Here we go. So right at the beginning of our application, we actually have to set up Serilog. So let me just grab that little bit of code. Here we go. So this might look familiar. So we just want to create a logger with new log configuration onto the minimum level of debug. We want to write to the browser console that we brought in, and we just say create logger. Now, so we've got the red squigglies. So if we control dot using Serialog, cool. So now our application should rebuild in the background. I refresh that, give it a second. Here's our application, and now, oh, look at that, it's working. Hey, we're using Serialog in the browser. I needed this button a moment ago. But yeah, that's exciting. Serialog in the browser. Now, why is Serialog so special for us? It's just console logging at the moment. But Serialog's got the ability to add multiple syncs. So we can actually send our logs back to the server or back to some other log ingestion service that we can then use to analyze the client-side logs and improve the application over time. So definitely a whole lot better than console.writeline. And this is something that existed long before Blazor did, and now we're running it in the code in the browser. Very exciting. So you can check out Nicholas Blumhardt's page here about Serialog and Blazor. Shows you some really cool examples of how to set up logging to a remote service. Give it a go. It's very cool. So moving on. Next, we have forms and validation. So we have edit forms, so the built-in controls in Blazor that gives us a few callbacks. So for instance, in this case, we've got we can specify our model first to say, this is the model in our code block that we're trying to bind to. So any change or any information added into the form is persisted in this model. But it'll only happen if it's all validated. And once it's validated, we can call it a validate handle valid submit method. Okay, try and say that fast 3 times. So like I said, here's the model, and we can add a data annotations validator. So we want to guarantee that the information being added into this form is in some sort of correct shape, meets some minimum requirements. And if they don't, then we can render that summary here at the bottom using a validation summary component. So the way that we decorate our components, our classes, is just with these data annotations. So we can make sure that the field is required and say that the string length is no longer than 16, and if it is longer than 16, we can then give it a custom error message. Okay, so I'm going to show you how to do that real quick. So if we go back to our application, I'm going to go back to VS Code, and let's see, I want to, first off, bring in a new file. I'm just going to add a new Razor component, and I'm going to call this edit forms.razor. And we're going to give this a page directive of edit forms. All right. Now what I want to do is I also just want to paste in my form. So I've got one prepared from the slides. Put that in here. And exactly what we saw before, we're going to have the model to our blog post, which we'll add in a second. We've got handle valid submit method, which is going to live in the code section. I'll bring that in as well. Here we go. So on the valid submit, we'll get the blog post model, and it's going to just print out some of the values that we've entered into the form. So that doesn't exist yet, so let's go and add that class. So I'm just going to add it right at the root level of this application. So blogpost.cs. Okay, so the code for this, nice and simple. We actually still have to just bring in, make sure we're doing everything in the right namespace. There we go. So it's a Blazor net user group. Here's my class. Just format that. I've got some red squiggles to bring in the data annotations namespace, and that should be it. Okay, cool. Now finally, I just want to add a link to our forms validation page. You see, I'm a C# programmer. Everything starts with squiggly brackets. Let's format that a little bit better. So we can see it's called edit forms, and just be very sure that these things are case sensitive. So let me just fix that up. That should be lowercase or lowercase. Fantastic. All right. So we save that. If we go back to our Blazor application, I refresh the page, here we go, forms and validation. Cool, and here's our edit form. You see if we go straight away and click publish, you see here's the validations that have failed. Excuse me. And they're rendered in that validation summary block at the bottom of our form. And you see everything that is invalid has a red highlight over it. So let's just add something for the title, click publish, and yep, it's gone away. Add something in there. So on change, it revalidates everything. And so for instance here, let's just put something that's nice and long, see if it complains. Yep, slug is too long. Cool. So and then if we click the publish button, nothing's happening. So if we just make sure that everything validates, it's still too long. Oops, let's put something in there. All right, let's click publish. And then here, we've got a valid submission and the information we've typed into the form is displayed in the DevTools in the console. Very cool. But I have a problem with this. I'm not a big fan of these data annotations. So I'm just going to delete them. I don't like them. I don't like decorating my entities with these things. It just ties me to something that, if I want to refactor my application, I definitely have to either take it away or bring it with me. So I'd rather not bring with me at all. I want to use something a little bit cooler. So I'm going to open up the terminal. I'm going to add a new package. And this is the Blazor Fluent Validation NuGet package. Fluent Validation. Spell that correctly. Yep. And what this lets us do is we can actually, hang on. What did I do? Did I type that correctly? Add Blazor. Sorry, it's a different thing altogether. There we go. Blazor.fluent validation. Excellent. There we go. All right, so I can close that. Don't need this anymore. We don't have to do anything to our blog post at all. We just need to add a new file. And this is actually added in the same file. We'd need to actually add the validator for this model. I'll show you how that's done. Like this. So we've got a blog post validator. It's an abstract validator for that blog post. I'm just going to add the using, get rid of all the red squiggles. And here in the constructor, we can specify all the rules that our blog post needs to follow for it to be valid. So the title must not be empty. The slug also must not be empty, but we want to restrict the length to a minimum of 3 characters and a maximum of 16. And content not empty. Cool. All right. Then in our edit forms page, what we can do, instead of using this data annotations validator, I'm going to comment that out for now. And what we can do is use the fluent validation validate. Well, let me just shorten that a little bit. So let's see. We can go and take all that stuff out and then add the using to the top of our file. So you can see here. Now we have a using for fluent validation. That's it. So we can use the same validation summary, but the actual validator is going to use the fluent validator. All right, so that should have built by now. I'm going to refresh the page. And now, straight away, I'm going to click publish. All right, same validation messages here. They must not be empty. So I'm just going to add something in here. And we can see now, it's already got a really cool validation error message. I didn't have to add that myself. Fluent validation worked it out for me. It even says how many characters I actually entered. Cool. All right, so here we go, all the other ones. So we can make sure that there's something in there. We pass that validation and click publish, and there we go. Our information shows up in console. So now we've got edit forms and fluent validation. Much, much nicer. What do you think about that? So, okay. Warning, incoming JavaScript. So even though, Blazor is all C# and .NET, we can still run JavaScript in our applications. I'm going to show you how. All we need to do to run JavaScript is to bring in the JavaScript runtime. In this example, I've got a button that calls my call.js method. That's in my code section. And then on the right-hand side, you'll see here, I've got in the index file a a global method reply to .NET that says, I love you, Blazor. So as soon as my users clicks this button, it'll invoke the reply to .NET function and return a string value. And we're going to bind that to the JS text value, which we're displaying in the markup here. So pretty cool. You can still run JavaScript in Blazor. And what it actually means is that we can still bring in NPM packages into our Blazor WebAssembly application and then wrap them up into a Blazor component. So you can reuse that really rich NPM ecosystem out there, as well as our NuGet ecosystem. So we actually have the sort of the best of both worlds, which is really cool. So yeah, definitely you can run JavaScript in the browser still with WebAssembly, Blazor, and .NET. Everything's working together very nicely. Everyone's friends. And yeah, cool. So you're probably thinking, I need to show you something really, really awesome. And I'm going to show you how to build a Markdown editor very, very quickly. And I'm not going to give away the code hints first, but let's just do this here. So what we want to do is, again, I'm going to bring in another couple of packages. So this one's called MarkDig. This has been around for many years, and it's a very popular library that people use to take Markdown files and render that into HTML. But I'm going to add one more package. This one's called markdig.syntax highlighting. Yeah. What this allows us to do is, if we have a code block in Markdown, so C# or PowerShell or whatever we want to use, then the Markdown is going to add some syntax highlighting to our rendered output. So it's pretty cool. All right, so those have been added. Don't need that anymore. So just to get to our page, I need to add one more nav link. So let's see what we've got here. Paste that in, fix the formatting. So this is going to be editor. I'm just going to rename that to Markdown editor. Then I need to, before I forget, go and initialize the Markdown pipeline. And the way we do that is, got the code here. So we just want to inject, set up the dependency injection for the Markdown pipeline. So we've got to bring in the using statement. There we go. So we're creating a Markdown pipeline builder. We want to use the advanced extensions. So we can render lists and all sorts of things and tables. And also want to bring in the namespace for the syntax highlighting extension. And then we're just going to build this pipeline and register that as a singleton. So that means if we have a razor component, I'm just going to call that editor.razor, because that's the route that we want to give it. Editor, that's what we specified in the nav menu file. So I'm also just going to add the @code section. And what I want to do is I want to have a text area on the left where I type in my Markdown, my raw Markdown, and then on the right-hand side is when I want to show the rendered version. So the way that we need to do that is, also we have to bring in the, we have to inject the Markdown pipeline. Markdown, I'm going to have to add the using first. Okay, then I can inject the Markdown pipeline, and we're just going to call it pipeline. I'm going to call it pipeline. There we go. Now I know I'm also actually going to use Serialog. Let's arrange that a bit nicer. Here we go. Okay. So I've got some code pre-prepared. And let me just grab that and put that in here for you. All right, like I said, here's a text area on the left, and we want to have some our rendered code on the right-hand side. So I haven't added the C# code yet, but I've got two fields I want to bind to. One's called Markdown text, the other one's called preview. Now, in the code section, I'll bring this bring this code in for you. All right. Okay. Let's just format that all. Okay. So just to make it clear, I've got a text area that I'm data binding the markdown text field towards, and I'm making sure that I'm binding to the on input event. So as soon as I hit a keystroke, it binds to my markdown text string and updates the view. And I just got to fix the typo here. I'll just call this HTML to render. That's what I actually want to render. So the way that this works is that I call the markdown pipeline, the markdown static helper to HTML. I give it the markdown text. If there's no text in there, just make sure that it's an empty string because it doesn't like nulls. And we just give it the pipeline that we set up and inject it into this component. Now I know because there's a small little bug that happens when you have a certain bit of bad markdown, and it just throws a null reference exception. And we're logging that as well, so we'll see what happens. And so that is all we need. That is going to give us a markdown editor in the browser. Let's see. So I'm going to go back to the browser. I'm going to refresh my application, and let's see. All right, we have a markdown editor. Awesome. Okay, nothing at this address. Editor. What did I do wrong? Editor. Demos. No matter how much you plan. All right, so I've got editor there. It's called editor. Nav menu. Did I call editor? Oh, I think I did everything right. Is it building? Let's double check. Next one. Yeah, they're built. Let's just refresh that again. Might be going a bit too quick. Ah, here we go. All right, here's my text area. So if I'm typing in here, I can see on the right there's some, and it's not quite markdown, rendered markdown. So hash goes to H1. Okay. Heading. All right, so it sort of works, but it's not actually working totally correctly. So what we're getting on the right-hand side here is the actual HTML, but I actually want to render that. I don't want to just see the HTML. Now, the reason for that is that in our component, what we're doing is we're basically just displaying the HTML string. And that's it. We're just displaying it as a string. This is the HTML that we get back from the markdig to HTML method. Now, there's something special that we can do in Razor. We can actually cast this string into something special. There we go. So if we cast that to a markup string and we just build our application, what's going to happen now, if we refresh, what's going to happen now, if I go, here we go. We have Markdown being rendered. Let's try that again. We've got heading 2. It's working. Very nice. Item, yes, we've got bullet point lists. It's all working. And go, look, mum. JS, very cool. So, we can do something really cool. Like I said, I want to do some code. So if I go CS, you see here, we've got a bit of error being output in the console. And if we didn't catch that error, it would actually sort of, crash our page, which is not nice. So if we catch that error, I'm just logging it. I'm not rethrowing it. Don't yell at me, but it's just to catch that little bug. So now, if I actually go and write some C# code, and it's doing the syntax highlighting for me as I type. Let's make a little cool method here on our Hello World class. Let's call it wave. And let's see, can this do something special? Can we? Yes, we can add emojis. Look at that. We have C# being rendered as Markdown in the browser, and all happens very easily with hardly any code. How cool is that? Really, really cool. Let's make it bigger so you can see it. There we go. Awesome. Very, very nice. I'm very happy with this. So, just to recap, a Markdown editor in Blazor will require 2 packages, markdig and a markdig syntax highlighting. We set up the markdig pipeline with just a couple of lines of code, and set up a text area where we can have some text input, and we convert that to HTML that we want to render with the static method. And then we just use this very special markup string that takes our text and injects it directly back into the DOM as actual markup instead of just plain text. So that's really exciting, very nice. So now the hard bit of parsing, markdown, and rendering it's done, and then we can add some custom controls to add our formatting and some rich editing for our markdown files. So not too much effort, and you've got a nice full-blown markdown editor. So what else can we do with Blazor? So I didn't cover this in the code, but we can do some state management. So right now, everything we do is in memory. And if we go and use dependency injection with some sort of an application state class, that's also going to be held in memory. So what that means is that if you go to another tab or a new window, that state is not shared. It's only for that particular tab. It's in memory. So if you close that tab, it's gone. If you navigate away from that page, then it's going to only be available to that application as long as it's still in the same tab. Now, the way to solve that is we can use local storage or session storage. So those packages are available. And if we want to store something a little bit more secure, we can use protected storage. But just to be aware that anything that is on the client side, so it can somehow be unobfuscated and inspected. So try not to put connection string to your database or anything secret in there. Even though it's harder for someone to try and get to that information, they can ultimately still get to it. So just be aware of that. But we can go a little bit further. We can use Blazor State and Blazor Redux. So if you have followed the NGRX patterns in Angular, you can use Blazor Redux. You can get all your actions and reducers and sort of keep that immutable state running through your application. And you get that the normal Redux tools in DevTools, so you can rewind and replay the state of your application. It's really cool. And it's a really nicely written library, Blazor Redux. So I think anyone that likes that sort of stuff should give it a go. I didn't talk about layouts and theming, but certainly you get all the components you need to do that for your applications. And you can also do some component unit tests using a library called bunit. Like the name alludes, it's very similar to sort of XUnit. You can write facts and theories to test your Razor components. What this library does, it makes it much easier to set up a host to render or to execute your components. And then you can just go and use the familiar assert methods to and test and make sure that the applications do what they're meant to do. Now, just like with the Angular world and React, there's a lot of component libraries out there, and they're starting to pop up for Blazor as well. So there's definitely some really good ones, Blazor, Radzin, Matt Blazor, Blazorize. They're all free, lots of cool components. Definitely should check them out. I think they're all pretty much worth it. And then Telerik, Syncfusion, DevExpress, and all the other big boys, they've got some sort of trial periods for their components, but definitely enterprise ready. They're really good, and they're all sort of aiming for sort of Blazor native components rather than rewrapping existing Angular or JavaScript components into Blazor. Certainly trying to take make use of WebAssembly's performance to write some really cool components for our applications. Cool. So now we know how to very quickly build a Blazor web application. We know why we have Blazor, and we saw a few cool little demos of how to build something in Blazor and how easy it is to use. Now, we need to talk about Blazor in the enterprise. And when we talk about enterprise, we always have to end up talking about clean architecture. How do we build our applications to be testable and for it to sort of withstand the test of time? But Blazor's superpower is definitely shared libraries. This is something really cool. It means that the code that I write, the shared code, I can use that directly in my WebAssembly, Blazor WebAssembly application, and in my Web API. So I can take any of the sort of shared models here and transmit them across the wire as is, and just deserialize it directly into that concrete type. I don't have to be concerned about, is it exactly the same shape, and add additional weird error handling just in case it's not the right thing. This is nice and easy. And this is the simplest way of building a Blazor WebAssembly application with a backend API, and it certainly is very nice. But just to be aware is that you have to be careful what you put into the shared code. You don't want to put your sort of business logic or your application into the client's hands, because they can inspect that code and ultimately unobfuscate that and inspect it and see how it works. And if you want to give away your secrets, that's your choice. But if you want to be serious about it, just be careful. So when we then look at building something a bit bigger, we're looking at clean architecture. So what clean architecture lets us do is to build the core of our application, in this case, application and domain. It's independent of any other frameworks. Everything inside of core is testable. We can definitely describe all that behavior and lock it down with some unit tests. And it's independent of any UI. So it doesn't matter if it is Blazor, Angular, React, Vue, Aurelia. It doesn't matter. Application is unaffected. And it also doesn't matter which database we use. If it's Cosmos or EF Core, or SQL Server, doesn't matter. There's no external dependency. We don't rely on something else to build our application core. And as you can see in the diagram, all the dependencies point inwards, and that is really what sort of allows us to keep our application core, sort of in a state that will sort of even outlive Blazor. It'll be there forever. It's all testable, and nothing's going to interfere with it. But then, like I said, we got the shared code from Blazor. So where does that fit? Some people might be tempted to sort of put some of that shared code and use it in application layer. So we can have some DTOs or something from the shared library in application, so that we can then hook that up to the Blazor UI, nice and easy. But the problem is that now our application layer is depending on something external. And we can also see that, we've got a dependency arrow pointing outwards. No longer is everything pointing inwards anymore. And the problem with this is that if the shared library changes for any reason, we're changing the shape of a DTO or anything you have in there, it's got quite a big blast radius. So you're going to have to change application and anything else that depends on application, such as your infrastructure. So you're going to have to then go and write something to make your infrastructure work again with this new shape of information, or your presentation layer, whatever applications you have in there, so console or web API or whatever, they will also be affected. So I don't think this is a great way to go, because as soon as you start trying to share your application layer, then things get messy, and I think you're going to end up with a whole lot of spaghetti code. So I don't think this is a good way to go at all. You might then be tempted to take the idea into a layer between application and presentation. It almost makes sense, but the problem is that even though dependencies all point inwards, now our infrastructure layer is depending on a shared library. And what that's going to sort of lead to is that we have to write all this unnecessary mapping code to get stuff jumping between the layers. And I don't think that's necessary whatsoever. So what we need to do is keep things simple. The core of our application is 100% testable. It's on its own. Whatever presentation layer we use, it's inconsequential. It doesn't matter. So anything that we want to do to make use of the shared code should happen just outside onto the presentation layer. We want to keep that just between the UI and our web API, for instance. So that shared code can definitely live there. I think that's definitely a much nicer place for it to be. Even though it looks like there's an arrow that points both ways, that's fine. I think if that's what you're aiming for, that web API for that UI, and if that suits your needs, I think then that's fine to do it that way. But we can go and make it just a little more simpler. So we can, instead of writing that code, we can actually generate that code. So just like how we do that with Angular and React, etc., using NSWAG, we can generate a C# client instead of a TypeScript client. There's a few other options, auto REST and Open API, but there's something new coming, which is very exciting, and that's in C#9. So we've got source generators. So we can actually generate a client that will consume our API, not just through controller actions and so forth, but even if we want to give them a particular way to call mediator queries and things in the front end and implement the Redux pattern for them, we can actually have that all ready to go. So all that the view or our components need to rely on is to bring in this client, and then it's all abstracted away. So they don't need to know that it's calling HTTP, or it could be gRPC or proto buffers, whatever. It doesn't matter. So we can actually go ahead and do some really cool stuff, but we have to wait a little while for the source generators to be generally available. It's in preview at the moment, but it certainly is looking very, very exciting. If you want a few more resources about clean architecture, check out Jason Taylor's clean architecture solution template on GitHub. It's a .NET CLI template that you can spin up a whole new project, and it's got everything you need to get going with clean architecture. If you want to just read a few more rules about it, you can also check out the SSW rules of clean architecture page. So we know now how easy it is to build a Blazor application. We know why we have it. I've convinced you now it's so super easy to use and that you should use it. And just looked at a little bit of architecture and what we should do for building something with Blazor in the enterprise. And now I just want to look at how we're going to take our application and run it in the cloud. This is very easy. So all we need to do is, because it's a static website, we can publish that to Azure Storage or to GitHub pages. We just .NET publish, and we have a bundled application, and we copy that to the storage account, and we're pretty much good to go. We can then actually go a bit further and go completely serverless. We can add a CDN onto the storage account, so we can get our application spread across the world, nice and close to all of our users. And if there needs to be an API, most people would default to an ASP.NET Core API, but we can also use Azure Functions, and we get that elastic scale. So because we're going to write some really awesome applications that 1,000 people per hour is going to sign up to our website. So we need to use something that scales really quickly, and Azure Functions with Cosmos DB, for instance, we can get that global scale happening pretty easily. So I think that's a pretty good combo that we can make use of. So the application that I wrote, all the code examples and things that we showed earlier, you can find that if you scan this link, you can access that application on your phone or on your laptop. And inside of that, we'll have a link back to my GitHub repo where you can get all the source code and start playing with Blazor on your own. And to rehost that, it's very easy. You just go and create a static website in Azure. You spin up a storage account, click the static website option, copy your files to it, and that's pretty much all that's required. It's super easy. And just need to sort of highlight a few things that's up and coming with .NET 5. It's only a few months away, but so here's some improvements for Blazor WebAssembly. They're going to bring in lazy loading. So when we have really large applications, it means that we only load just a small subset of DLLs that we need for that part of the application instead of the whole lot, which is what's happening currently. So it downloads everything and it loads everything the whole time. So they're going to improve multi-threading in the next version. So definitely some great performance benefits. They're going to add CSS isolation, protected browser storage. Like I mentioned that earlier in the talk, but it's an optional package right now. But they're going to sort of bake that into Blazor WebAssembly. They're going to add in the async disposable pattern, so that it's sort of a lot of asynchronous services that we need now, and we need to dispose of them in an asynchronous fashion. So they're going to bring that pattern in for us as well. Drag and drop ability, and a really good one is ahead of time compilation. So that has been delayed to .NET 6, but because it takes a lot longer to build our applications, but it optimizes it even further than it is now. And we're going to have some massive speed improvements with Blazor when it comes out with .NET 6. So that's going to be Blazor LTS. And also the live hot reload, which was scheduled for .NET 5, but they had to delay that to .NET 6. But it's still okay because we have that auto rebuild, and it also gets us halfway there. But ultimately, live hot reload will be pretty cool to have. So in today's talk, we had a discussion again about how quick and easy it is to build a Blazor WebAssembly app. We know why we have it and then why we need to use it, and what it means for the enterprise. We can build some pretty cool applications with Blazor and how easy it is to run in the cloud. And in summary, Blazor is awesome. I think it makes it very easy now for a lot of back-end C# developers to call themselves full-stack developers. Yeah, just a bit more HTML and CSS and some Razor, and hey, you can have a full stack on your LinkedIn profile. I think we're going to see some really interesting software architectures coming soon with, the combination of Blazor and things like the source generators, and just some new ideas of how we can write really cool, really rich .NET client-side applications. I think it's going to be really awesome to see what comes up. And there's some really nice improvements for Blazor coming in the next sort of 18 months in .NET 5 and .NET 6. And sometime next year, I think we're all going to be running really awesome Blazor applications. Thank you.